Hi guys, welcome to Memo's Tutorials. We are continuing with our topic of homeostasis, and today we are looking at the regulation of carbon dioxide levels in the internal environment. Remember, we breathe in oxygen and we breathe out carbon dioxide, but then remember, we don't control our breathing. It's not a voluntary thing. I don't tell myself to say, memory, now breathe faster or breathe slower. So what controls that, so that at the end of the day, I don't have a higher concentration of carbon dioxide in my blood. Remember, carbon dioxide is the waste product, right? So what happens is, when your carbon dioxide levels in the blood increase, meaning they are above normal expected levels, we have the receptor cells in the carotid artery, in the neck, these ones, they are stimulated. Once they are stimulated, they then send impulses to the medulla oblongata in the brain, right? So if you still remember the functions of parts of the brain, the medulla oblongata is for the involuntary actions, which includes breathing, right? So what the medulla oblongata does, it stimulates breathing muscles, right? Your intercostal muscles and the diaphragm and also the heart, they are stimulated, right? Once they are stimulated, your breathing muscles, they contract more actively. This contraction, it increases the rate and depth of breathing, and also your heartbeat a little bit faster, okay? So what it simply means is that when your carbon dioxide levels increase in your blood, the medulla oblongata is stimulated, and once it has been stimulated, it responds by causing the target organs, which is the heart and the intercostal muscles together with the diaphragm, they are stimulated to make you at the end of the day to breathe more and more faster. The more faster you breathe, the more carbon dioxide is taken to your alveolar cells, right? To your air sacs, and the more carbon dioxide will be exhaled. At the end of the day, as we are exhaling more and more carbon dioxide, at the end of the day, your carbon dioxide levels, they will come back to normal, right? That's for carbon dioxide regulation. But then we have another very important regulation mechanism that we need to know and be familiar with. It's osmoregulation. Osmoregulation, we are focusing on water. Your water has to be maintained at a constant level. It mustn't be too high and also mustn't be too low. So we'll start with a case when your water levels they are less than normal. They are below normal. So what happens is the hypothalamus is stimulated. The hypothalamus, I hope you still remember, is the one that has got the Adh hormone. The hypothalamus is the one that controls the amount of water in our bodies, right? So once the hypothalamus is stimulated, it then sends impulses to the pituitary gland to secrete more ADH, antidiuretic hormone, right? So this ADH, what is it going to do? It's going to travel in the blood to the target organs, which is the kidneys. So what it causes, when it reaches the kidneys, the ADH increases the permeability of the collecting on the collecting ducts and the distal convoluted tubules of the kidneys, meaning it's going to make these CT and the DCT tubules to what? To allow the permeability of water, to allow water to enter, all right, to allow water to be reabsorbed. So at the end of the day, there will be more reabsorption of water, and this water is then passed to the surrounding blood vessels, right? And the water level in the blood then retains to normal. At the end of the day, you will give you urinate a more concentrated urine because we have absorbed water, reabsorbed more water into the system, right? And then we move on to cases when your blood has got more than normal water levels. The hypothalamus is stimulated again, and it sends impulses to the pituitary gland. And what the pituitary gland does this time, it stops secreting the ADH. It stops secreting the ADH, or it starts to secrete less and less ADH. So when we have less ADH, the antidiuretic hormone, it simply means that our kidneys, they are not going to they are not going to be permeable. The collecting ducts and the distal convoluted tubules, they are not going to be permeable to water. They will not allow any water to be reabsorbed, meaning all the water is going to be passed onto our urine. Less water is going to be absorbed, or no water at all is going to be absorbed back into your blood vessels, right? And more water is going to be lost. So as you are losing that water, it's going to retain to the normal level. Once it gets to the normal level, then we are good to go. So when you're reading these diagrams, you always start from the normal levels, water levels in the blood. So these normal water levels, when there's an increase, so when there's a decrease in the water levels, the pituitary gland secretes more ADH, and this ADH causes the permeability of the collecting ducts and the distal convoluted tubules, meaning more water is going to be reabsorbed. And once more water is being reabsorbed into the blood, at the end of the day, it reaches the normal state, right? But when the water levels are way too high in the blood, it simply means now that the pituitary gland is going to be stimulated, but that means it's going to stop secreting ADH, or it will secrete a very small amount of ADH. And once that has happened, it means your collecting tubules and your the DCTs, they are not going to be permeable to water, or their permeability decreases. So once that less water is being reabsorbed, it means more water is going to be lost through urine. As we are losing more water, it simply means it's now getting back to our normal levels that we desire, right? So our last regulation is the regulation of salt. To say the salts, we must have a constant internal environment for our salts as well. So we'll explain that on our next video. Okay, the salt and also temperature as well, and that will mark the end of chapter 8.